Hello, boys and girls. In this video, we are going to cover about IP address. When we are talking about networking, the very first thing that you need to understand is the IP. Why do we need IP? What does it stands for? What's the functionality behind it? So let's take a look together. IP stands for Internet Protocol. An Internet Protocol address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. An IP address serves two main functions. One is host or network interface identification, like it's computer information, and the second function is the location of that computer. So compare IP address with your own home address. We need our home address to send and receive mail and provides the location services. So this is our home, and to get our emails, sorry, not emails, like a regular emails, packages and stuff, they come to our home how? Through an address. Just like that, if you wanted to have some guests over to our home, we provide them the address of our homes so they could come or even put in the GPS to come to our home. So when you are at home, an IP address is assigned to your computer by your internet service provider, also known as ISP. So in United States or in New York where I am, there are these internet service provider like Time Warner Cable, Optimum, AT&T, or Verizon. And I'm sure you have different names, different companies where or which region you belong to. Since they are the ones giving you access to the internet, it's their role to assign an IP address to your computer. Your internet activity goes through them and they route it back to you using your IP address. And of course, for that, you have to pay for that service. Moving on, IPv4 addresses are usually represented in dot decimal notation. Now, what is IPv4? IPv4 stands for Internet Protocol version 4. And by the way, that we will cover right after this. So, again, IPv4 addresses are usually represented in dot decimal notation, consisting of four decimal numbers, each ranging from 0 to 255 separated by dots. For example, 192.168.123.13. I'm putting them into a different color so it will be easier for you to identify the different digits. Each part represents a group of 8 bits, or that is also referred to as an octet of the address with a total of 32 bits. I'm sure you remember we talked about bits or bytes. So those bits and bytes are represented. They are zeros and ones. So the first octet are 8 bits, second 8 bit, and when you add all those bits together, they are 32 bits. So for example, the dotted decimal IP address, which is 192.168.123.132, is in binary notation. When you convert that decimal in binary, that comes in 10000 and all that big number, right? This number may be very hard to make sense of, right? So divide it into four parts of 8 binary digits. So let's go ahead and do that. So these 8-bit sections are known as octets, right? The example IP address then becomes like this. This is 1100000000 dot 101 and so on. You got the point, right? So now it's a little easier. Now this number makes a little more sense now. So it so to make it even simpler, convert it into dotted decimal format. And when you convert these bytes or these bits from 0 and 1 to decimal, then you will see it will become as 192.168.123.132. So basically, behind the computer, all communication happens with 0 and 1s. So to make it more human readable, we convert that into decimal, and that decimal becomes the IP address of the computer. All right, now we'll talk about the versions. There are two IP versions. One is IPv4 and IPv6. IPv4 is an older version which has a space of over 4 billion IP addresses, meaning IPv4 version can have or can assign IPs to no more than 4 billion computers in the world. However, the new IPv version 6 can provide up to trillions of IP address to fulfill the need of all internet users and devices. Of course, computer internet is becoming bigger and bigger, right? So that is why IPv4 has this limitation. Now we need IPv6. So let's look at example of IPv4. It has these 8 bits in each digit in octet. So 192.168.1.30. When we are talking about 6, look at this number. It's huge, and you could imagine how many computers it could serve with this IPv6. A lot of companies are still using, or a lot of people still using IPv4, but eventually, maybe a year, 2 year, or sooner or later, everyone will change it to IPv6. Now let's look at how to find IP of your computer. So let's say if you have a Windows machine. I have a Windows machine. I'm going to go to my search and I'm going to type it CMD. And this will open up a command prompt for me. In the command prompt, I'm going to type ipconfig and hit enter. When I'm going to hit enter, it's going to scroll down pretty fast. And right here, you're going to see when I typed in ipconfig, Windows IP configuration, Ethernet adapter, Ethernet. So right here, it says IPv local IPv6 address. See how long is that? This is what I'm talking about. This is the IPv6 address. IPv4 address that's assigned to my computer is this 10.253.1.48. And this is a subnet mask and gateway which we will talk about in the later lecture. Other IP addresses that you see, this one is for my VirtualBox that I have installed on my computer, which is a virtualization software. So if you do not have that virtualization software on your computer, you're probably not going to see it. The next one is for another software that I have. It's also a virtualization, and this is the IP for that virtual box or that virtualization from VMware. But anyway, focus on this one. This is the IP of my computer, and that's how you pull the IP of your Windows computer through ipconfig command. Now, if you have a Linux machine, you could run ifconfig command to get that IP. All right, moving back to our slide. IP address can be private or public, meaning you have a computer, it connects to your modem connects to the internet or your service provider. Now, from the modem to your home devices, everything is given a private IP. And usually it is like 192.168.1.x. But in the outside world, there's another IP that is assigned to your computer, and that is called public IP. For example, if I wanted to know what is my public IP, again, I could go to my Firefox and go to Google, and I could type what is my public IP. When I hit enter and what is my public IP address, you could click on the first link, that's fine. You're going to see your public IPv4 is 47.17.51.191. This is my IP that has been given to me by my internet provider. This is not the same IP address that I have right here, right? So this is a private IP which is internal to my system, and this is the public IP that everyone else in the world can see. All right, going back to our slide. So when we have this private IP of our modem assign IPs to all the devices that connects to that modem or router. So in this case, I just picked up that IP 192.168.1.5. Then there are two types of IPs. One is static and one is DHCP. Static IP is the IP that is assigned to your computer and it does not change. Even you reboot your computer or do whatever the configuration changes you do, it does not change. And your ISP provider will have to charge you to assign a static IP. Then there is a second type of IP which stands for Dynamic Host Configuration Protocol, DHCP, and that is based on a leasing, meaning your modem which is right here, that modem has a built-in DHCP setup, and every time it sees a device coming to it and asking for an IP, it assigns a DHCP IP. And as soon as that device shuts down or shut off, it takes that IP back and assign that IP to someone else. All right, then we have every website has an IP address. So, for example, when we input the URL google.com in your browser, it gets translated to an IP address by DNS. So let's look at our computer. We go to modem and modem go to the internet. And when we request, hey, I wanted to go to Google, there's a DNS server out there by Google and by other computers, which by the way we'll cover about the DNS. DNS stands for Domain Name System. We'll cover about it all in the later lectures. That DNS server is out there and it translates your request from Google to an IP address. And that's how it connects to the web server because google.com is a human readable, not a computer readable. That is why there is like a cheat sheet or a translator out there on DNS server which says, hey, I got a request for google.com. Let me find out its IP, and it transfers that IP. Now, internet addresses are allocated by the company name Internic, the organization that administered the internet. And that Internet NIC is registered service mark of the US Department of Commerce. It is licensed to Internet Corporation for assigned names and numbers. They are the one who gives that IP. They are the one who manage the IPs in the world. Anyway, it was a lengthy lecture, I understand, but my intention is that you really understand what IP is, what are the terms used for, or what's the technology behind the IP addressing. I'll see you in the next lecture. Hello everyone. In this video we are going to talk about the subnet mask. Subnet mask is one of those three pieces that you need to have the TCP IP communication among computers. One is the IP address, second one is the gateway, and third one is the subnet. All right, a subnet is a logical subdivision of an IP network. The practice of dividing a network into two or more networks is called subnetting. Computers that belong to the same subnet are addressed with an identical most significant bit group in their IP addresses. A subnet mask is used to divide an IP addresses into two parts. One part identifies the host, which is the computer. The other part identifies the network to which it belongs to. The subnet mask is used by TCP/IP protocol to determine whether a host is on the local subnet or on a remote network. So, to summarize it, we need subnetting on our computers or our network to avoid a lot of bandwidth or a lot of traffic from one system to another. So, if it's a local traffic or local communication, it doesn't have to go to the router, it could stay local. That's why we need subnetting. Anyway, to understand it better, let's draw it out. So let's say we have these three computers, and their IP addresses are 192.168.1.2, 1.3, and 1.4. And these three computers are connected to a switch, and switch is connected to a router. The router has an IP of 192.168.1.1. Now, in some cases, switch and router is the same piece of hardware. But in our example, let's say we have these two different pieces of hardware. Now, on this network, we have an IP address and we have a router. And when we define the subnet mask of 255.255.255.0, that means this one, it has two parts to it. One is that first part, and second is the last zero. And what that means is 192.168.1, that it's telling that this is the first piece, and 0 is dot x, which means anything that has after 192.168.1.x can have the communication directly. They don't have to come to the router, and router doesn't have to route it to some other network. So stay that within the network. So now let's take an example of another network, and that has 192.168.2.2, 3, and 4. Same network connected to a switch, switch connected to a router, router has an IP address of 2.1. All right, so in this case, let's say if I wanted to talk to 192.168.2.2 from my um, host 192.168.1.4. And in that case, I have a subnet 192 subnet of 255.255.255.0, which means that if I have to communicate anyone from 192.168.1. Anything, it will say local. But if it is not that, I have to go through my switch. Switch goes to a router. Router goes to another router, and that router sends the traffic to the switch. Switch to that host. That's how it works. Now, if I had the subnet mask of 255.255.0.0, that means this is first part, which is 192.168 anything, anything. So if I need to connect to 192.168.1.4 based on that subnet, what this host is going to try to do is going to go directly to 192.168.2.2. And what will happen? Whoop, it can't find it because that's a simple, completely different network. That's why you need to have this subnetwork, which will keep the traffic within the same network, and anything that is outside, if it has to go anything from this side, it will go to the other router. That's why this is not going to work. All right, moving on, there are three major classes of IP addresses subnets. Class A, Class B, Class C. Each classes have a different supportability of the networks and host. There are also two other networks which are rarely used, Class D and Class E. All right, let's look at how to find subnet masks of your computer. So I have my Windows computer here, and I'm going to go to Start menu and type in Command Prompt. In the Command Prompt, I'm going to type in ipconfig, and I'm going to scroll up because I have a few network. And right here, you see I have covered IPv4, which is this address. We have covered the default gateway, and subnet is right here, which is defined at 255.255.255. Anything that within this IP range can stay within the local network. Anything that asking to go from this to that, then it has to go to another gateway or another network. All right. Similarly, we're going to go to our Linux machine right here. And in this Linux machine, the command that we have to specify is ifconfig. In the inconfig, I'm going to scroll up again. And right here, this is my network card. And you're going to see this is my IP address. This is my subnet mask right here. And if I wanted to know the gateway in Linux, I have to type in the command netstat minus rnv. You're going to notice the gateway is right here 0.0.0 or 10.0.2.2. So all the traffic that's coming to this to within this network will go through that gateway. Anyway, I don't want to confuse you any further. Just remember subnetting is used to divide the traffic so you don't have to go through one highway to another, just like a regular example of the highway. If you wanted to go from one city to another, it's better that you stay on the highway. If you wanted to if you wanted to go from one town to another, most likely you will have to go through the local roads. It's just the same concept. Hello, everyone, and welcome to the section of networking. Networking is also one of the important component in IT in computers. When we want to communicate with other computers and share some files or get onto the internet. So the very first lecture that we wanted to cover is how computers communicate. To connect to an internet and other computers on a network, a computer must have a NIC, which stands for Network Interface Card, installed and a network cable plugged into the NIC port on one end and plugged into another computer's NIC port. So this is how a NIC looks like. This is a like just like a card that you mount on the motherboard slot, a dedicated slot. In front of it, it has a metal strip which has a port on it where you could connect the Cat5 Ethernet cable. When you look at that same card mounted on a server, it looks like this. It has this ports that are pointing on the outside of the computer, and inside is actually that card. And the port and the closer look of that port is like this, which has two lights, a static or link light on it. Now, computers need to be connected to one another through Ethernet cable. That's Ethernet cable, aka or also known as Cat5 as a short, or as a whole, it's category 5 of wiring. So let's look at our computer. This is a computer, and we connect our computer with that Cat5 cable, and we connect with another computer. Now, of course, if you want to connect it directly to another computer, you could use Cat5 or you could use a crossover cable. And then you could share files between these computers or communicate to that computers through its sharing software installed on the operating system. Now, like a phone line, Ethernet cables can have 4 or 8 wires, as much as double the amount found in a phone line, to connect to other computers on the internet. Cat5 cable must be connected to a computer port that we already talked about, and then to a cable modem or DSL modem or a router or a switch that is provided to you by your ISP. ISP stands for Internet Service Provider. So once again, here we have our computer and there is a port on our computer, and we connect a cable, Cat5 cable, onto that port. Then the other end of that cable gets connected to our modem or router. And then that router gets connected to outside world. But before it gets connected, it actually that modem or router assigns an IP to your computer. You need that IP to communicate to the internet. So again, once that is connection and once that IP is assigned, it gets connected to the outside world. And from that modem or router, most of the time you're probably going to see a coax cable connecting or that's going to your ISP, or maybe a fiber cable. So anyway, that's how computers communicate. If you want the computers to communicate between just two computers, then you could just simply connect them to the crossover. You don't need a modem or router. But if you want to connect to multiple computers or on the internet, then you do need a router, switch, or modem. Hey folks, and welcome back. In this video, we are going to talk about gateway. Gateway is one of the three elements that are needed to have a proper communication among the computers. We know we need a computer or server needs an IP address. Then we need a gateway and we need a subnet mask. So, a gateway is a hardware device that acts as a gate between two networks. It may be a router, firewall, server, or any other device that enables traffic to flow in and out of the network. It allows computers within the local network to send and receive data over the internet. So, for basic internet connection at home, the gateway is the internet service provider that gives you access to the entire network. So, your ISP provider, if they gave you a modem or a router, that is a gateway to your network, to your computers. Gateway can provide hardwired network or Wi-Fi network. So for Wi-Fi network, it basically stands for wireless fidelity. So we could connect our computers through a Cat5 cable right into the port of our router, and we could have connection to the outside world. Similarly, there are Wi-Fi routers or wireless routers that allows you to communicate without having a hardwired cable. And I'm sure everyone nowadays using Wi-Fi. All right. A gateway has an IP address just like any computer, and most of its IP addresses ends with 1. So most of the time you're going to see any gateway that you're dealing with has an IP address of 1. For example, 192.168.1.1. And all the other devices connected to the network or going through that gateway will have all those corresponding IPs. A home ISP gateway serves the DHCP server purposes as well to lease out IP addresses to requested devices. All right, let's take a look at our computer and find gateway and what is the gateway of my computer. So for that, you have to go to your start menu and go to the command line and type that command again, ipconfig. move or scroll up. And right here, you're going to see default gateway. My default gateway is 10.253.1.1, and my computer IP address is 10.253.1.48. So all the traffic that is coming from this computer, dot 148, if it has to go outside, it will go to this gateway, this router that has this IP address, and this router is the one that's going to send traffic outside and receive the traffic. Hey everyone, I'm sure by now you have a very good understanding of an IP or what is an IP. Now let's take a look at the TCP and see what is the difference between the TCP and IP. And I'm sure you have heard of TCP before. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol, which we already covered. Now, Bob Kahn and ARPA and Vint Cerf at Stanford University published research in 1974 that evolved into the Transmission Control Protocol and Internet Protocol, the two protocols of the Internet Protocol suite. That is why most of the time these two people are to referred as the founder of Internet and how the Internet functions. All right, TCP and IP are two separate computer network protocols. IP is the part that obtains the address to which the data is sent. So you have to know the address, where to have to send, and that's the responsibility of IP. Whereas TCP is responsible for data delivery once that IP has been found. Okay, this protocol is responsible for managing the connection between a client and a server, making sure that data which needs to be transferred is split into several packets which will all eventually reach their destination. If they don't, or if one of them is corrupt, TCP defines how the missing data will be retransmitted. When you configure the TCP/IP protocol on Windows computer, for example, the TCP/IP configuration setting require an IP address, a default gateway, and a subnet mask. Now, regardless of it's a computer, Windows computer, or Linux computer, or any other computer for that matter, if you want to have that computer to be able to communicate to the internet or other computers, it has to um, it has to comply with the TCP/IP configuration requirement. And that requirement says in order for you to go from one place to another, you gotta have an IP address. You gotta have a default gateway and you gotta have a subnet mask. We know what an IP is, but what is a default gateway and what is a subnet mask? Well, for that, stay tuned. We will cover that in our next lecture.